Hello class, today we're going to learn lesson 4.7, which is about using isosceles and equilateral triangles. So just to review, we have talked about isosceles triangles before. They are a triangle with at least two sides congruent. They could have three sides, but it's at least two sides. And an equilateral triangle is where all three sides are congruent, or the same. So it is important to learn some vocabulary about the parts of a triangle. First, we're going to talk about vertex angle. So in this triangle below, I see that this side and this side are the same. They are congruent due to those two tick marks there. So that means that this triangle is isosceles. Now the vertex angle is this angle right here. That's the angle that is in between the two sides that are congruent. So that is the vertex angle. So I'm just going to identify that. It's right there. The legs of a triangle, that is the two sides that are, I'm going to say in this case, congruent. They're the two sides that are on either side of the vertex angle. Okay, they're the same. Where I'm going to skip ahead to the base of the isosceles triangle. And that is like, in this case it's on the top, but a lot of times you can think of it as like the bottom of the triangle. It's the side that is directly across from the vertex angle. And then the last thing that we're going to talk about, and this one's really important, are the base angles. So that would be like these other two angles that are on either side of the base. So that would be this angle, and the other base angle would be right here. So it's really important that you're able to identify these different parts of this isosceles triangle. If you want to pause the video right now and just think about all of those different vocabulary words, that would be great, or rewatch the video if need be. Okay, so now that you've got those vocab words down, I'm going to talk about a couple of theorems and corollaries. So first of all is the base angle theorem. What this is saying is that if I know that two sides of a triangle are congruent, so like let's say this side and this side are congruent, then that means that the base angles, so this angle and this angle, are equal. It also goes the opposite direction. So if I know that these base angles are congruent, this angle and this angle are congruent, that then means these two sides are congruent. So it goes both ways. The next theorem is, I'm going to call it the corollary to the base angles theorem. And what a corollary means is you take a theorem or a rule and you can learn something else from that or create another rule from that one. So basically all you need to understand is the context of this, okay? You don't have to memorize what it's called. But it says a triangle is equilateral if and only if it's equiangular. So that means if I know that this triangle, all three sides are the same, they're equilateral, that means that all three of these angles are also the same. It also goes the opposite direction. So if I know all of these angles are the same, that's going to tell me that it's equilateral, that all sides are the same. Now from that rule, I can also gather one more piece of information, and I can say that if I have an equilateral triangle, all three of these angles are 60 degrees. Because if you think about it, if they are all the same, that means I have x plus x plus x is equal to 180. What is 180 divided by x? It is 60 degrees. Alright, so we're going to use that information today in order to complete the following examples. Example 1, it says if triangle FGH, or in this triangle, FH, so this side, is congruent to GH, that side. Name two congruent angles. So this would be like our base angles theorem. Okay, so going back up here, if I know that these two sides are congruent, that means the two base angles are congruent. Okay, so since these two sides are the same, that means that the base angles right here, F and G, are the same. So I'm going to say angle F is congruent to angle G. Okay, example 2. Find the measure of RST. I'm going to look at this triangle. I'm noticing that all three of these sides are all 3 meters. That means the triangle is equilateral. If it is equilateral, I know that all three of these angles are the same. And the reason I know this is because of this corollary right here. Okay, so if all three angles are the same, that means that each angle is 60 degrees. So I know that angle R is congruent to angle S, and that's congruent to angle T, and all of those equal 60 degrees. All right, flipping it over to the back side. It says, example 3, the pattern below is present in a quilt. Explain why triangle ADC, here's ADC, explain why this purple triangle right down here is equilateral. Okay, well, taking a look at this, I'm noticing that AD and DC are congruent. So I see that AD is congruent to CD. So those two sides are congruent. If that is true, or since that is true, then I know that, let's do a different color here. Then I know that this angle right here, DAC, would be congruent to my other base angle, which is DCA. So that's by the base angles theorem. Because these two sides were the same, that means that these two angles are the same. Okay? Well, in this diagram, this also shows us that this angle right here is also the same. Okay, so this triangle, triangle ADC, is equiangular. We just found that out. Okay? If a triangle is equiangular, then I know that triangle ADC is equilateral. All right, and that is why. Again, that would be because of that corollary that we looked at on the first page. If something is equiangular, it is equilateral right here. Okay, let's look at example 4. It says complete the statement. So if FH, so FH is right here, if this side is congruent to FJ, this side, then that means that angle H is congruent to angle J, the other base angle. Okay, I'm going to erase this because the next one might be different. Might be talking about a different triangle. It says if triangle FGK, so this triangle right here, this blue one, is equiangular. Okay, so that means I'm going to mark all of these angles. And FG is 15, so I'm going to write that down. FG is 15. Then FK, so how long is FK? Well, if it's equiangular, that also means that it's equilateral, so all three of those sides are the same. So all three of those sides are also 15 units. Okay, let's go to example 5. Solve for the following variables. Letter A here. All right, so I'm going to take a moment and I'm going to look at this. The first thing that I'm seeing is that this angle and this angle are the same. So, since this first angle here is 8y minus 7, that's the same as the second angle, 6y plus 5. Okay, so I can set those two equal to each other because they're marked the same. And now let's go ahead and let's quickly solve. So I'm going to combine my variables. I want to get rid of that 6y. What's the opposite of a positive 6y? Minus 6y. 8y minus 6y is 2y. All right, trying to get my variable by itself, so we want to undo minus 7 with a plus 7. So we have 2y is equal to, let's see, 5 plus 7 is 12. Opposite of 2 times is divide by 2. So y is equal to 6. Okay, so that's part of our answer. Y is 6. We also, there is an x in there, so we have to find that as well. Okay. Now let's see here. To help me out, let's go ahead and let's just find how big is this angle now that I know that y is 6. So if I plug 6 right in there for y, I have 6 times 6, which is 36, and 36 plus 5 is 41. So this angle right here is 41 degrees. That also means that this angle is 41 degrees. Okay, so let's see if that helps us at all. Now I'm going to go ahead and I'm going to look at that other triangle. Here's this purple triangle, and it tells me that these two sides are the same. So, I'm going to think to myself, that's an isosceles triangle, so if this angle, base angle on the left is 4x, that means that the base angle on the right is 4x. Okay, and now let's see, does that help me out knowing that these two angles are 41? If you remember from a previous lesson, we learned the exterior angle theorem that states that this angle, this 4x, is equal to the non-adjacent angles in the other triangle. So 41 plus 41. Okay, 41 plus 41 is 82. How do you undo 4 times? You divide by 4. Okay, and 82 divided by 4 is 20.5. So x is 20.5. Okay, that one was a little tricky, but that's okay. We got through it. Let's take a look at letter B. That's our last example. Alright, so taking a look at this one, the first thing that I noticed is that we have an equilateral triangle right here. And when we have an equilateral triangle, that also means all angles are the same. It's equiangular. And remember that every single equiangular triangle has angles of 60 degrees. The other thing I'm noticing is that this right here is marked as a 90-degree angle. Okay, so that means that what plus 60 is 90? What plus 60 is 90 degrees? Well, that's 30. So that means that this right here, this angle is equal to 30 degrees. So I can write down that 4x minus 2 is equal to 30. Okay, let's go ahead and let's solve for x now. How do you undo minus 2? You plus 2. So now we have 4x is equal to 32. And how do you undo 4 times x? You divide. So x is equal to 8. Okay, so we have one of our answers. We also know that we need to solve for y. Okay, so now let's go and let's look back at our work here. I'm also seeing that in this red triangle here, that this side and this side are the same. So that means it's an isosceles triangle. Now, we already found that this base angle is 30. In an isosceles triangle, my two base angles are the same. So that means that that one is 30. So we can say that 7y plus 9 is equal to 30 degrees. Okay, and let's do our normal solving. Opposite of plus 9 is minus 9. So 7y is equal to 30 minus 9 is 21. Opposite of 7 times is divided by 7. So y is equal to 3. Y is equal to 3. All right, we found our x and y. Thank you so much